Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the solutions of the problems that have appeared in the IIT JAM mathematics examination held in 2025. In this video, we discuss the solutions of three problems from the section Real Analysis, which are related to the concepts and results related to sequences and series. This video is the second part out of the three parts. These questions are suitable for all these examinations. Right. This is the question number 20 and it is for 2 marks. It is a multiple choice question. The given question is, let x1 is equal to 2 and xn plus 1 is equal to 2 plus 1 by 2xn. 2xn is in the denominator for all n belongs to n. Then which one of the following is true? We are given 4 options. Option A, xn plus 1 greater than or equal to 4 by xn for all n belongs to n, and xn is a Cauchy sequence. Option B, xn plus 1 less than 4 by xn for some n belongs to n, and the sequence xn is a Cauchy sequence. So these are the 2 items that are intertwined, option C and option D also. Right. Let's now discuss the solution of the problem in detail. We are given x1 is equal to 2 and xn plus 1. The n plus 1th term of the sequence is 2 plus 1 by 2 times xn for all n belongs to n. We will first prove xn plus 1 is greater than or equal to 4 by xn for all n belongs to n. Now, it may be seen that each term of the sequence is positive. x1 is positive and each xn is positive for all n belongs to n. We are given xn plus 1 is equal to 2 times 1 by 2xn for all n belongs to n. That means xn plus 1 is greater than 2 for all n belongs to n because 1 by 2 times xn is positive. So 2 plus some positive. So xn plus 1 is greater than 2 for all n belongs to n. Because xn plus 1 is greater than 2 for all n belongs to n, xn is also greater than 2 for all n belongs to n. So xn plus 1 greater than 2, xn greater than 2 for all n belongs to n. Multiply, we'll get xn plus 1 multiplied by xn is greater than 2 into 2, that is 4. For all n belongs to n. So that means xn plus 1 multiplied by xn is greater than 4 for all n belongs to n. This implies xn plus 1 is greater than 4 by xn for all n belongs to n. This is the truth. But it is given xn plus 1 is greater than or equal to 4 times xn for all n belongs to n is also true. So that therefore the given statement xn plus 1 greater than or equal to 4 times xn for all n belongs to n is also true. Right. Now, we discuss a concept called contractive sequence. And this definition you can find in a book by, Introduction to Real Analysis by Bartley and Sherbert. The definition is, we say that a sequence xn of real numbers is contractive if there exists a constant c where 0 less than c less than 1 such that modulus of xn plus 2 minus xn plus 1 is less than or equal to c times mod of xn plus 1 minus xn for all n belongs to n. Is obviously a contractive mapping where the number c is called the constant of the contractive sequence. We have a theorem. This theorem says every contractive sequence is a Cauchy sequence and therefore it is convergent. This definition and this result you can find it in the textbook entitled Introduction to Real Analysis by Bartley and Sherbert. This concept and this result we are going to use now. Right, this is what we have. We want to prove the sequence xn is a Cauchy sequence. Now, we take modulus of xn plus 2 minus xn plus 1 is equal to modulus of xn plus 2 is 2 plus 1 by 2 xn plus 1 minus xn plus 1 is 2 plus 1 by 2 xn, 2 cancels and you will get modulus of 1 by 2 xn plus 1 minus 1 by 2 xn. Right, take the LCM. Then you will get 1 by 2 into xn minus xn plus 1 by xn plus 1 xn under the modulus. And each term is positive, therefore 1 by 2 xn plus 1 xn will come out. There is no need of taking modulus because all the terms are positive. And modulus of xn plus 1 minus xn. And now this is less than or equal to 1 by 8 times of modulus of xn plus 1 minus xn. Why? Because xn plus 1 xn is greater than or equal to 4 for all n belongs to n. For that reason, this will be 1 by 8. And this 1 by 8 works out to be c, and this is 0 c less than 1. So, modulus of xn plus 2 minus modulus of xn plus 2 minus xn plus 1 is less than c times modulus of xn plus 1 minus xn, where c is 1 by 8. Note that the c is 1 by 8 is such that 0 less than c less than 1. Therefore, the sequence is a contractive sequence. If it is a contractive sequence, then it is a Cauchy sequence, and it is a Cauchy sequence of real numbers, therefore it is also convergent. So recall, every contractive sequence is a Cauchy sequence, and it is a Cauchy sequence of real numbers, and therefore it is convergent. So what we want is this sequence is a Cauchy sequence. So therefore the sequence xn is a Cauchy sequence. Thus xn plus 1 is greater than or equal to 4 by xn for all n belongs to n. That is the first statement. And the sequence xn is a Cauchy sequence. So recall the option A, xn plus 1 greater than or equal to 4 by xn for all n belongs to n, and the sequence xn is a Cauchy sequence. Thus option A is true. The answer to this question is option A. Right. We move to question number, the next question, right? Right, we move to question number 21. It's for 2 marks. It's also a multiple choice question. Agreed. For n belongs to n, define xn and yn by xn is equal to minus 1 to the power of n into 3 power n by n cube and yn is equal to 4 power n plus minus 1 to the power of n into 3 power n whole to the power of 1 by n. Then which one of the following is true? We are given 4 options. Option A, xn has a convergent subsequence and no subsequence of yn is convergent. And these combinations are only repeated in options B, options C and options D. Let's now discuss the solution of the problem in detail. We have xn is equal to minus 1 to the power of n into 3 power n by n cube and yn is given like this. First, let us take the first sequence, the sequence xn. Where the nth term xn is equal to minus 1 to the power of n into 3 power n by n cube. Note that 3 power n dominates n cube. Why? 3 power n is exponential, n cube is a polynomial. And we know exponential growth always dominates the polynomial growth. Therefore, limit n tends to infinity of 3 power n by n cube is equal to limit n tends to infinity of 3 power n by n cube is infinity by infinity form. We have used L'Hopital's rule, that is the so-called L'Hopital's rule. That is the derivative of the numerator 3 power n into ln 3, derivative of the denominator 3n square. Again, infinity by infinity. We have used again L'Hopital's rule. Again, it is infinity by infinity. Again, we have used L'Hopital's rule. So we see here. So the denominator is factorial 3. Limit n tends to infinity of 3 power n is infinity. So it is infinity. So further, this sequence xn oscillates. Why it oscillates? Because of the presence of minus 1 to the power of n. Right. So now let us take the even indexed terms x to n. That is 3 power 2n by 2n whole cube. So each is positive and it tends to infinity as n tends to infinity. Let us take the odd indexed terms, that is minus 3 power 2n minus 1 by 2n minus 1 whole cube, because minus 1 to the power of 2n minus 1 is minus 1 and it is negative. It tends to minus infinity as n tends to infinity. So there are two subsequences, which one is diverging to plus infinity, the other is diverging to minus infinity. So thus the sequence xn diverges. Why? Because we have seen two subsequences which are diverging, one diverging to plus infinity, other diverging to minus infinity. Therefore, the original sequence xn diverges and oscillates rapidly. So any subsequence of xn, any subsequence of xn will be? It's either diverges to plus infinity or diverges to minus infinity or oscillates. That means no subsequence of xn converges. So no subsequence of xn is convergent. So that is the fact. Right. We move to the second solution yn and discuss the convergence of a subsequence of it. Yeah, this is what we have seen. Option 2, case 2, yn we have 4 power n plus minus 1 to the power of n into 3 power n whole to the power of 1 by n, n belongs to n. Now, we take n is even. When n is even, minus 1 to the power of n is plus. So yn is 4 power n plus 3 power n to the power of 1 by n. When n is even, yn is an to the power of 1 by n where an is 4 power n plus 3 power n greater than 0 for all n belongs to n. Agreed? Agreed. Now, how to talk about the convergence of this yn? For this, I remember Cauchy's second theorem on limits. And this result says, let an be a sequence of positive terms if limit n tends to infinity of an plus 1 by an is L, then limit n tends to infinity of an to the power of 1 by n is also L. So we want limit n tends to infinity of an to the power of 1 by n. For that, we will compute limit n tends to infinity of an plus 1 by an. Now, limit n tends to infinity of an plus 1 by an is limit n tends to infinity of 4 to the power of n plus 3 to the power of n plus 1 by 4 to the power of n plus 3 to the power of n. This is all when n is even. This is called limit n tends to infinity of, in the numerator, take 4 to the power of n plus 1 common. In the denominator, take 4 to the power of n is common. Then, and limit n tends to infinity, 4 to the power of n plus 1 by 4 is 4. 4 times limit n tends to infinity of 1 plus 3 by 4 to the power of n plus 1 by 1 plus 3 by 4 to the power of n. Limit of the quotient is equal to quotient of their limits. Limit of the numerator by the limit of the denominator. And limit n tends to infinity 3 by 4 to the power of n plus 1 is tends to 0. So this will be 4 into 1 by 1, that is 4. So thereby Cauchy's second theorem on limits, limit n tends to infinity of an to the power of 1 by n is 4. So that is limit n tends to infinity of yn is 4 when n is even. When n is even, it tends to 4. So thus, when n is even, collect the subsequence of even terms. The subsequence yn, when n is even, that means you are collecting the subsequence of even terms of the sequence yn is convergent and converges to 4. That means the sequence yn has a convergent subsequence. Thus, what we have proved is no subsequence of xn is convergent. That's what we have seen in the last slide. And now we have seen yn has a convergent subsequence converging to 4. So let's look at the option B. No subsequence of xn is convergent and yn has a convergent subsequence. Therefore, option B is true, and the answer to this question is option B. That is the detailed discussion of the solution of this problem, and it is a good question. Right. Right. This is the question number 25. It's again for 2 marks for the multiple choice question. The given question is, let x1 is equal to 1 for n belongs to n. Define xn plus 1 is equal to 1 by 2 plus sine square n by n in brackets multiplied by xn. Then which one of the following is true? We are given 4 options. Option A, sigma n is equal to 1 to infinity xn converges. Option B, sigma n is equal to 1 to infinity xn does not converge. One of them will be true. And option C, sigma n is equal to 1 to infinity xn square does not converge. Option D, sigma n is equal to 1 to infinity xn into xn plus 1 does not converge. So let's now discuss the solution of the problem in detail. We are given x1 is equal to 1, xn plus 1 is equal to 1 by 2 plus sine square n by n in brackets xn for all n belongs to n. So very clearly that xn is positive for all n belongs to n. Now xn plus 1 is equal to 1 by 2 plus sine square n by n in brackets xn. Right. We have to talk about the series sigma n is equal to 1 to infinity xn converges or not. For that, why not we try, these are the terms of the series are positive. Let us try D'Alembert's ratio test. Xn plus 1 by xn is equal to 1 by 2 plus sine square n by n. Take the limit n tends to infinity xn plus 1 by xn is limit n tends to infinity of, in brackets, 1 by 2 plus sine square n by n. That will be equal to 1 by 2 plus limit n tends to infinity of sine square n by n, and that is equal to 1 by 2 plus 0. So that means limit n tends to infinity of xn plus 1 by xn is 1 by 2, which is less than 1. So by D'Alembert's ratio test, if xn plus 1 by xn is L as limit n tends to infinity, when L less than 1, it is convergent. When L greater than 1, it is divergent. When L is equal to 1, we require further investigation. Right, it is less than 1. Therefore, by D'Alembert's ratio test, the series sigma xn converges. Right. Option A is true. Option B is not true. And it is a multiple choice question. Therefore, the answer to this question is option A. But our students will ask us, how would we, suppose this question is given under multiple select question, MSQ. So how do you take out, option C and option D? They are not true. How do you say that? So for that, let us take option C. Sigma n is equal to 1 to infinity xn square does not converge. We have x1 is this, xn plus 1 is given like this, and every term is positive for all n belongs to n. And we have seen sigma xn is convergent. And we recall a result here. If sigma xn is a series of positive terms and sigma xn is convergent, then sigma xn to the power of p is also convergent where p greater than 1, p belongs to n. Here we take p is equal to 2. So sigma, by using this result, sigma n is equal to 1 to infinity xn square converges. Therefore, this is converges, but in option C, it says does not converge. Therefore, option C is not true. Move to the next option, option D. Sigma n is equal to 1 to infinity xn plus 1 does not converge. Now, xn plus 1 is equal to 1 by 2 plus sine square n by n, in brackets xn, multiply throughout by xn. Then you will get xn plus 1 xn is equal to 1 by 2 plus sine square n by n, in brackets xn square. Take this series. The series n is equal to 1 to infinity xn plus 1 is equal to 1 by 2 sigma n is equal to 1 to infinity xn square plus sigma n is equal to 1 to infinity sine square n by n xn square. Let's call this as the series 1. It is the sum of two series. Right. In this, on the right hand side, 1 by 2 sigma n is equal to 1 to infinity xn square is convergent because sigma n is equal to 1 to infinity xn square is convergent. What about the second one? So, convergence of the series n is equal to 1 to infinity sine square n by n xn square. Now, let us take sine square n by n. This is strictly less than 1 by n, less than or equal to 1 for all n belongs to n. Yes. Sine square n, the maximum value will be 1. And multiply throughout by xn square. Xn square. Each xn is positive, xn square is also positive. So, inequality will be the same. Sine square n by n xn square less than xn square. Now, on the right hand side, sigma xn square is convergent. So is sigma sine square n by n xn square by comparison test. By comparison test, sigma n is equal to 1 to infinity sine square n by n xn square is convergent because on the right hand side sigma n is equal to 1 to infinity xn square is convergent. Right. So go back to sum of the series 1, capital 1. In that the first one is convergent, the second one is convergent, just now we have seen. Now the sum of two convergent series is again C is convergent, therefore this is also convergent. So from 1, sigma n is equal to 1 to infinity xn plus 1 is convergent since it is the sum of two convergent series. So option D, in option D it says it does not converge, therefore whereas it converges, therefore option D is not true. So option C is not true, option D is not true. The only option that is true is option A. So the answer to this question is option A. That is the detailed discussion of the solution of this problem. Right. And in this video, we have discussed 3 questions. They are looking very good. And practice questions on convergence, divergence of series. They are very important. They can even come in CSIR net also. Right. I am sure that you have understood the solutions of these 3 problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.